All right, so the velocity vector of a particle moving in the plane has components that are given by dx dt and dy dt. In a couple days, we're going to talk more about vectors, so don't let that get you hung up. But basically, they're just giving you the velocity of a particle. And since this is written in terms of parametric equations, we have a separate velocity for the horizontal component, and that's dx dt, and a separate velocity for the vertical component, which is dy dt. It also tells us that at t equals 0, the position of the particle is at -2, 3. All right, so for t between 0 and 1.5, find all values of t at which the line tangent to the path of the particle is vertical. So I'm looking for where I have a vertical tangent line. Drawing on what you did yesterday, where does a vertical tangent line? Where dx dt equals 0. Good. Is that the only condition? Good. Dx dt needs to equal 0, but dy dt cannot equal 0. So we're just going to literally use our calculators to figure out where dx dt equals 0. When you're using your calculator to solve a trig equation, do not use the home screen to solve a trig equation, because trig equations have an infinite number of answers, and you may not get the ones that are in the correct domain for that problem. So let's graph dx dt and see where it crosses the x-axis. So go to your y equals and type in dx dt, which is 14 cosine x squared times sine of e to the x. And since they tell you that the domain is just between 0 and 1.5, you might as well set your window for those x values. So go to your window, and for your x min, let's do 0, and x max 1.5. And then you're just looking at the values that you need when it graphs. All right, so when you graph it, dx dt between 0 and 1.5, it looks something like that. And you can solve that one of two ways. In y2, you could go back and put 0 and use the intersect feature, or you can just use the 0 feature of your calculator, which in my opinion is the easier thing. So under F5, number 2 is 0. Lower bound means to the left of the x-intercept. It's a lower x value than the x-intercept, and upper bound is right. Okay, so the first one that I got was 1.145. 1.145. And the other x-intercept is 1.253. Okay, and then you do also need to check to make sure that dy dt does not equal 0 at either of those 2 points. And on this particular problem, that's actually very obvious. Because if you graph dy dt between 0 and 1.5, so that was dx dt. Dy dt actually looks kind of like this. So I have two. Ooh, okay, I've kind of made a mistake in my notation here. What have I done? Yeah, I used x in my calculator, but we're really talking about t here. So I have two values of t for which the tangent line is vertical. Here. Yes?
This was a free response and you did an AP test and we put X, were they kind of wrong?
If this was a free response problem on the AP test and you put X, would they count it wrong? They might, because they asked you to find the values of t. And if you call them X, you're not really answering the question. All right, find the position of the particle at t equals 1. This question gets asked over and over and over and over again. So please put a star next to it so that you will never, ever miss it. I'm basically given the velocity, and I want to find the position. So what concept am I going to have to use? Integrating. Okay? So the position of the particle is going to involve an x value and a y value. So let's start with the x value. So how could I find the x position? What? Plug in 1. Okay, to what? You're right. We do need to plug 1 into something, but what? Right, I could plug 1 into the position function. So if dx dt represents the velocity, then the position function would be represented by x of t. Do y'all agree with that? Okay, so ultimately I'm trying to find x of 1. Okay, well, how do I find x of t? Integrate it. Okay, so integrate that on your calculator.
Get a review that's like broken up into that so we know what to
Of course. Okay, what's the and the interesting? Okay, when you integrate dx dt on your calculator, all it does is pull the 14 out of the integral and return that exact same answer. So what that means is that that function for dx dt, that is not the derivative of any known function. Okay, it's still a function that I can graph, but it's not just not the derivative of any other function. So we can't go about it like that. So another way to think about this is that if I integrate velocity, how can I find the displacement of the particle? Okay, the area under the curve of velocity. But if I'm finding the area under the curve, then I need limits of integration, correct? Okay, so redo that integral between 0 and 1. So find the integral from 0 to 1 of dx dt. Okay, why did I use 0 to 1? Okay, the position, I'm looking for the position at t equals 1, and my starting time from the given is t equals 0. So if I can find the displacement of the particle between 0 and 1, then that can help me with the position. Okay, did you get an actual answer for that? Yes. Okay, so, and what was the displacement? 315. Okay, so is that the same thing as the position? So how can I take that displacement between 0 and 1 and find the position at t equals 1? The particle basically moves 11.315 units to the right, since it's positive, between 0 and 1. So where does it end up? At what x value does that particle end up? Yeah, how are you getting 9 point something? Okay. So another way to think about the position, the x position at t equal 1, is take the starting position, which was -2, and then add the displacement of the particle between the time that it was at x equal -2 and the time that we're talking about. So we've got our starting position plus the displacement, and that would equal 9.315. Okay, so now that we've done all the legwork on x of 1, y of 1 is going to be much easier. So what's the starting, and the same thing would happen. Okay, what you were trying to do at the beginning by just integrating to find x of t and then plugging in a 1, in theory that should work as long as it's a function that you could integrate. Now don't forget that you would have to find c, but you could use c, but you could find c. If you could integrate, you would be able to find c because you had an initial condition. All right, but the same thing would happen with dy dt in that you can't integrate that. So y of 1 needs to be thought of as the beginning position, the beginning y position, which is what? 3. And then between what time period am I interested in the displacement? 0 to 1, right. Because the time when y was 3 was 0, and I'm looking for y of 1, or when t is 1. All right, so y prime of t dt. And you can type that into your calculator just like that. Do 3 plus the integral of dx, dy dt, and then comma x, comma 0, comma 1. And when you do that, you should get 4.621. And position is a point, so your final answer should be the point, 9.315, 4.621. That question gets asked over and over and over again about find the position of the particle, and they like to force you to think in terms of the beginning position plus the displacement by giving you functions that you can't integrate. I do want to talk about why the calculator wouldn't integrate dx dt as a indefinite integral, but as soon as you put limits of integration on it and it becomes a definite integral, the calculator will give you an answer. How did the calculator find the answer to that definite integral with the limits of integration? Right, it found the area under the curve of dx dt between 0 and 1. Whereas if you don't have limits of integration, the only thing it can do is find a function whose derivative is dx dt, and that evidently doesn't exist. So what the calculator was actually doing was doing an infinite Riemann sum between 0 and 1 to find that exact area under the curve. Okay, C, write an equation for the line tangent to the path of the particle at t equals 1. What are the two things I have to write the equation of a tangent line? Point and slope. Which one do I already have? The point, right. At t equals 1, I just found that the point is 9.315, comma 4.621. So I need the slope. And how do you find slope in terms of parametric equations? Okay, dy dx is always slope, but x and y are in terms of t, so I need to think about it as dy dt over dx dt. And if I'm trying to find the slope at t equals 1, I can even think about it as y prime of 1 over x prime of 1. And if you find those values in your calculator, you get 0.863. So the equation of the tangent line is y minus 4.621 equals 0.863 times x minus 9.315. That's the slope, and slope is dy over dx, which in terms of parametric we learned yesterday is dy dt over dx dt. So I plugged a 1 in for dy dt and a 1 in for dx dt, and then divided those answers, or just did it all on my calculator.